and admit everybody. Greetings, everybody. Thank you all for joining this meeting of the West County Water Quality and Recycled Water Supply Feasibility Study. This is your 5th Stakeholder Committee meeting on October 29th, 2025. As we've done with all of our other meetings, we will record this session. And I'll hand it over to Kent Gilfie from Sonoma Water in just a moment for opening. But real quickly, I wanted to walk through a couple of very quick logistical items. First and foremost, if you're not actively addressing the group, I would ask that you keep yourself on mute just to cut down on any background noise. To mute and unmute yourself, I think everyone's familiar with Zoom at this point, so I won't belabor that too much. We're not a huge group, so I would just ask, do keep yourself on mute. You do have the ability to mute and unmute yourselves. Once we get to a couple of the conversation breaks that I'll run through in a few minutes, I would ask that you use the hand raise feature to get in the conversation queue. And you can find that on by clicking on the reactions button at the bottom of your screen and then select hand raise, and that'll just let us know that you want to jump into the conversation. So with that, let me go ahead and hand it over to Kent for opening remarks.
Great. Thank you, Sam, and welcome everybody. As Sam pointed out, this is our 5th committee meeting, stakeholder committee meeting for this regionalization study that we're looking at. I just want to, again, thank everybody who has remained committed to this effort to get us here to committee meeting number 5 and sticking it out with us. So thank you so much. Really appreciate that. We are getting close to a major milestone, which is submitting the draft in accordance with the schedule that we have with the regional board to submit the draft feasibility study. November is just a few days away, and it's a late November that we'll be submitting that draft. The committee will have opportunity to review that, as Paris too. I think is going to get into some of those timelines. You all have been providing really valuable feedback to us, asking important questions, and you've helped us refine the process to get us where we're at to date. So thank you. Please continue to provide that feedback. Please continue to ask good questions or all questions. And again, thank you for that. So I also want to just thank our staff and our consultants who have played a critical role in helping us get here as well. So tonight we do have a full plate. There's a lot to go over. We're going to hear about some recycled water and some climate considerations, some updated costs and comparing the alternatives. So I don't want to take a lot of time. Again, much appreciation to everybody participating, and I'll let us get rolling. So I turn it back to you, Sam.
Great. Thanks, Ken. So real quickly, we'll do a round of introductions in a moment, but I want to read through our agenda real quickly. As we've done with all of these other meetings, Paris will kick things off with a quick review of the study's scope of work and timeline. This is actually going to be really important this time because it'll sort of showcase some of those touch points that you have in terms of reviewing the actual draft report and some of the next steps for the committee as a whole. But really the bulk of the time is focused on the comprehensive regionalization alternatives. So this is, it's a little bit different than the previous meetings. This is kind of, this is where it all comes together. We've talked about the alternatives, the concepts for the alternatives as kind of standalone pieces. We've talked about unsewered communities and recycled water a little bit as standalone pieces. This is where it all comes together. So you can see how all the different parts of the report fit. Catherine's going to deliver a pretty extensive presentation on those comprehensive alternatives. We will have a couple of conversation breaks throughout the slides just for clarifying questions, and I'll do what I can to keep us on track. It's literally going to be just a few minutes of conversation break between some of the individual presentation segments. But really the bulk of the meeting after that presentation is focused on your comments on the alternatives. This isn't the last chance that you have to take a look at all of these things, but it is your best opportunity to provide input on the alternatives before draft report is submitted to the North Coast Water Board. And Catherine will walk through all of that in her presentation. We'll spend just a couple of minutes wrapping things up and talking about next steps. And it's our goal to get you out of here by 6 p.m. So with that, I don't want to belabor things too much. Let me just do a quick round of introductions. If you could just tell us your name and the organization or interest group that's bringing you here today, that would be great. And I'll just read down through the list as it appears on my screen. So we'll start off at the top with Andrea Rodriguez.
Hi, Andrea with Sonoma Water, Community Engagement.
Thank you. Ann Dubay.
Hey, consultant for Sonoma Water, helping Andrea.
Thanks, Ann. Catherine.
Catherine Geese with West Coast Associates, technical lead for the study.
Thanks, Catherine. Parastu Hushiel Sadat.
Good afternoon, Parastu Hushial Sadat, project management for the feasibility study with Sonoma Water and Russian River County Sanitation District.
Wonderful, thank you. Chad Davison.
Yeah, Chad Davison, management consultant for Forestville Water District and Grayton Community Services District.
Thanks, Chad. Rich Homer.
Yeah, Rich Homer, a long-term resident of Villa Ground, and also a direct member of the board of directors for the Friends of Villa Ground. I'm president of the board of directors of the Sweetwater Springs Water District and a commissioner on Sonoma LAFCO.
Wonderful, thanks, Rich. Brenda Adelman. Brenda, I see you might be joined via two accounts. I'm not sure which one to unmute, but there we go.
Do you hear me now?
Important that you only join via one device and make sure that you're muted on both of them. I think that's what what was causing the feedback. We'll come back to you in just a moment. Carlos Diaz.
Good afternoon, everyone. Carlos Diaz, Deputy Director of Engineering over Capital Projects for Sonoma Water.
Thanks, Carlos. Cassandra Stinson.
Hi, I'm part of the grants and funded projects team at Sonoma Water.
Great. Thanks, Cassandra. Charles Reed.
Hi, everybody. I'm Charles Reed with the North Coast Water Board.
Thanks. Dan Fine.
Hi, can you hear me now?
Yes, thank you.
Dan Fine. I'm a member of the CAG, resident of Monterey.
Thanks, Dan. George Lincoln.
George Lincoln, Sonoma Water Operations Engineer for the Russian River County Sanitation District.
Thanks, George. We already heard from Kent. Let's go to Kyla Brook.
Hi, Kyla Brook. I'm a member of the CAG and a longtime resident in Villa Grande, and also a property owner of some amount in the Russian River.
Great, thanks, Kyla. Matt Herman.
Yeah, I'm Matt Herman. I'm Water Resource Control Engineer with North Coast Regional Water Board.
Wonderful, thank you. Tina Lowe.
Hello, everyone. I'm Tina Lowe, the Recycled Water Engineer, also with the North Coast Regional Water Quality Control Board.
Thanks, Tina. And Todd Hunsdorfer.
Hi, Todd Hunsdorfer with the Sonoma County Executive Office, Water Quality Analyst and Ombudsperson.
Great, thanks, Todd. All right. Did I miss anybody? Oh, and Steve Tripp.
Steve Trippy, also same as Dan Fine, Monterey resident, CAG member.
Thanks, Steve. All right, I think that's everyone. If I skipped over you, my apologies. Feel free to introduce yourself in the chat. And if any questions pop up for you as we're going through all of the different presentation materials, feel free to type those into the chat window, and we'll get them answered as soon as we break for discussion. I am sensitive of the time, though, and I know we have a lot of content to get through. So let me go ahead and hand things off to Parastu.
I am sorry, I don't see the slide screen.
Let me get that up there. Are others seeing it?
Yes.
Oh. Okay, sorry. So are we on slide 4 then?
It, yeah, so it should be the only thing displayed on your screen right now, if you're joined to Zoom, which I know you are.
Yeah, okay. I am
okay.
gonna just start. Sorry about that. I don't see the screen. This is the new laptop, and I wasn't able to like completely download Zoom correctly. Thanks everyone for joining again. Before we dive into the technical presentation, I would like to reiterate that the scope of work for this project is defined in the settlement agreement between the Russian River County Sanitation District and North Coast Regional Water Quality Control Board. This study is focused on 4 key objectives. First part of the scope was to assess the feasibility and potential benefits of combining 4 existing wastewater districts, including Russian River County Sanitation District, Occidental County Sanitation District, Grayton Community Services District, and Forestville Water District in this region. We analyzed their sewer treatment capacities and costs of operations and how regionalization could improve those services. We identified top 5 regionalization alternatives in the first part of the scope, and then evaluated opportunities for those alternatives to provide wastewater services to unserved communities, specifically the communities of Hacienda, Hollydale, Monterey, Villa Grande, Camp Meeker, and Guerneville. In today's presentation, we will look at how much recycled water could be made available for use and how regionalization would impact our resiliency to natural hazards and climate change. Also, I would like to reiterate a few key points. 1, there is already a dedicated feasibility study focused on wastewater treatment for Monterey, Villa Grande, and our work will build upon the findings of that study. 2, when we refer to connections, we specifically mean potential connections to wastewater treatment plants, not to existing collection systems. 3, we also acknowledge that fundings and governance present important challenges for these alternatives. And finally, again, this is a high-level assessment, and we are not designing or constructing any facilities at this stage. Next slide, please. This timeline provides an overview of our schedule and outlines technical workshops and committee meetings. We kicked off the process with the service area description workshop in August 2024 and held the final stakeholder committee meeting in October 24. Earlier this year, we presented potential regionalization options along with the selection criteria and scoring methodology and selected top 5 regionalization alternatives. We also explored opportunities for unserved communities to potentially connect to the regionalization system. In today's meeting, we will have a complete presentation for that top 5 alternatives, with considering unserved communities, recycled water options, and climate change resiliency. Ahead of today's meeting, we shared a summary of the discussion topics, and I hope everyone had a chance to review the materials. Next slide, please. So as we move forward, the next major milestone is submitting the draft feasibility study to the North Coast Regional Water Quality Control Board and the Stakeholder Committee by end of November to meet the requirements of the Enhanced Compliance Action. The committee will then have time until January 2nd, 2026 to review the document and provide feedback. We will reconvene on January 12th to discuss and review those comments together. After that, a revised draft addressing the committee's input will be submitted to the North Coast Regional Water Quality Control Board in early February. You can see that some of the dates are still tentative, but this schedule ensures that everyone has sufficient time to review the material and that the study reflects both technical findings and the stakeholder perspectives before it's finalized. Thank you. With that, I'm going to turn it back to you, Sam.
Wonderful. Thanks so much, Perstu. So
Thank you.
important information. You'll actually see this slide later when we break for discussion as well, just as a reminder on kind of where we are and what some of the next steps are. Appreciate that overview, though. Now, at this point, I want to go ahead and hand it over to Catherine.
All right, thank you very much. So we have 4 kind of major topics or subject sections of the presentation today. I'll be discussing the recycled water supply evaluation portion of the work that we did. Really, it's more about looking at how the recycled water supply can be utilized within the West County area. Then we will be talking about the analysis with respect to the facilities and the existing on-site treatment systems with respect to climate change and resiliency and impacts that will happen, could happen, or propose to happen to flooding related to climate change impacts, increased rainfall. Following the overview of those 2 sort of subset evaluations that we completed, we will dive back into then looking at all of the alternatives that we previously presented, the 5 alternatives, where now we've incorporated the unsewered community clusters that we talked about at the last meeting, the flows and loads, and the cost associated with incorporating those projects. And then we'll present a comparison of those alternatives at the end and a discussion about recommendations that have come out of the study. With that, we'll dive right in and try to go through these first few slides fairly quickly because we do have a lot of content to cover. So with the recycled water analysis, what we really, for this work, what we were trying to identify was, how much recycled water use is in the region. Taking a look at the areas around the Forestville and the Grayton Community Service District treatment plants, we first started with an assessment of the existing demands and the existing vineyard demands based on some input that we received that, the vineyards really don't use a whole lot of recycled water. What we indeed confirmed was that the existing vineyards that are served by the Forestville and Grayton system are effectively at capacity. They cannot take any more water than what they do take, which is a departure from the first phase of the analysis that we did. Taking that into account, we took a look at how much additional land would be needed if we did some of these regional alternatives and identified a pretty significant expansion would be needed. So we went and looked at all of the agricultural uses in the area, the irrigated uses. There's some GIS information that Sonoma County put together, which is shown here on this figure. And as shown, most of the irrigated lands outside of the parcels that are already irrigated are indeed vineyards. And what that means is that if any expansion of reuse in the area of Forestville and Grayton is likely going to have to involve vineyard use, which means a pretty extensive system would be needed if a lot of recycled water had to be disposed of via irrigation. Next slide. For the other part of the evaluation, we did identify other uses that have a lot of possible need. And in particular, there are 2 quarries that are located near Forestville that one of them, in fact, currently uses potable water that could take recycled water. And so we did look at incorporating that into the analysis, as well as expansion of some of the existing municipal uses within the community of Forestville. Next slide. In the area around the Russian River treatment plant, which is the green box shown at the bottom there, you can see that right around the facility there is very little irrigated area. And that is a significant limitation for this plant. If it takes on more flows, where could that water be disposed of? Basically, given the lack of local irrigation demands, and the knowledge that Russian River currently has a significant amount of property surrounding the treatment plant where land disposal is possible. For this study, we concluded that it didn't make sense to make a major investment in recycled water infrastructure, and instead, any additional summer season disposal would occur on the properties that surround the treatment plant. But that possibly municipal reuse within the areas of Guerneville or, perhaps around the Northwood Golf Course could be explored at a later date. But it's unlikely that these would provide very significant additional demands. Next slide. Another thing that we took a look at, we had input from the city of Windsor, the town of Windsor, as well as from the regional board about, if we were to export water out to Windsor or Santa Rosa for that matter, that bringing recycled water back to the West County area would probably be desirable since there's existing recycled water users there. We didn't want to lose that opportunity. And so we also learned through our work that the town of Windsor's recycled water system and discharge location actually bring their flow a pretty significant distance closer to about halfway the distance to the Forestville plant, as shown on the figure here in the upper right-hand corner. And so assuming we could pick up the water from that discharge point into Mark West Creek, only about 3.7 miles of pipeline and about 3 MGD with the 3 MGD pump station, we could bring recycled water back to the Forestville recycled water storage pond from where it could be distributed to customers. So we've incorporated this infrastructure into the regional alternatives to look at, again, kind of adding that benefit back into those options. Next slide. Similarly, with Santa Rosa, their system is shown on the right-hand side, and the blue triangle there that's in the middle with the red arrow pointing to is a storage pond that is used by City of Santa Rosa, the Laguna plant, for recycled water. And so if a pump station were constructed there, water could be delivered to the recycled water storage ponds at the Grayton wastewater treatment plant and then distributed to those customers. So again, with about 3.7 miles of pipeline, about half the distance to the treatment plant proper, and about a 3 MGD pump station, we could bring that recycled water back. And that infrastructure has also been included in the Laguna wastewater treatment plant export options. Next slide. So I'm going to go through the climate change and resiliency, and then we'll pause for questions. So with climate change and resiliency, the climate change resiliency discussion, next slide, please. What we did was there was some information available through Sonoma Water on increased flood frequency associated with increased rainfall and more intense rainfall that would occur as anticipated to occur with climate change. So what we did is we took a look at both the treatment plants and the unsewered parcels to see how they would be impacted with those changes. So with respect to the treatment plants, both Russian River and the Grayton Community Service District treatment plant are mapped near existing floodplains, as shown in these two figures. However, Forestville and Occidental are not within floodplains and are unlikely to be impacted by flooding with climate change. Next slide. So for the Russian River site, we looked at the increased flood frequency and depth that would potentially occur with climate change. And we found that The site would maintain resiliency with a 100-year event, even with climate change, except for the emergency storage pond, which would potentially be inundated in a 500-year event under current climate conditions. But in a 500-year event, in the most extreme climate change scenario, a larger portion of the Russian River site could be impacted. But generally, it's fairly resilient to climate change. It's built up out of the floodplain, and the slope continues to go up away from the floodwaters. So with the exception of the emergency storage basin, the facility is fairly well protected. At the Grayton Community Service District site, there is actually already a flood wall that protects the main treatment facilities, which has about 2 feet of freeboard. And then the storage ponds, which are located north of there, have even more elevation above the floodwater. However, with climate change, depending on how much the flood level changes, the Grayton plant could be impacted. The one thing we'll note is that the floodplain here is a Atascadero Creek, which was not modeled as part of the Sonoma Water evaluation. So we extrapolated results from the Russian River to this watershed, which probably overestimate the flood impacts that would occur here. And so there is more investigation that would be needed to really understand the potential climate change impacts on the Grayton plant. But given the fact that it already is flood protected by a flood wall, any increase above that 2-foot difference could become problematic. Next slide. So we also took a look at all of the unsewered parcels in the study area. And basically we looked at within the community clusters that we talked about at the last workshop, and we'll be revisiting here in a minute if you forget what those are. But the 12 community clusters that we identified for this evaluation, we first took a look at how many parcels within those clusters would be impacted just under current flood conditions. And as you can see from the leftmost column here of data on the slide, clusters 1 through 7 and cluster 12 are all within the existing floodplain, whereas 8 through 11 would not be impacted. With climate change, the percent of parcels impacted generally increases in all of the clusters that are within the floodplain, but a few of them remain fairly low, with 4 to 6, or just a couple of individual parcels potentially impacted. Next slide. So I'm going to pause here and say that the information that I just provided is incorporated into the analysis of the alternatives. So what I just provided to you is just a high-level overview of the additional information gathering we did. And then in the next few slides, I'll talk about how that was incorporated into our analysis.
Great, thanks, Catherine.
With that, I can pause for questions.
Wonderful. I know that there's one point from Todd in the chat that I encourage staff to take a look at. It's more of an FYI about looking towards future potential uses for recycled water. But I want to check in with everybody and see if there are any clarifying questions. And again, we'll have plenty of time to kind of get into the weeds a little bit to see how all of these different things are applied to the comprehensive alternatives in a little bit, but any clarifying questions for Catherine on recycled water or climate change resiliency? See one hand up from Steve. Go ahead, Steve.
Yeah, could you go back over that last slide? I'm not exactly sure that I understand. The maps are, I don't understand the maps, but.
Yeah, the maps are just kind of a screenshot showing maybe a depiction of the analysis. So if you take a look, you can see on the figure on the top, there's a pink line that's drawn that shows the boundary of the current floodplain. And then those blue parcels are currently inundated. Correct. And then with the climate change impacts, the increase in flood level, with the green parcels that are just beyond that boundary would be impacted. And then with the late climate change scenarios, the pink parcels also become impacted. So basically what we're showing is how that floodplain expands with the climate change scenarios. It's just really just showing how the data on the right was generated, but it's not intended to show all of the parcels. It's just giving an example.
Got it. Under baseline certainly just means current.
Yeah, baseline is current 100-year flood conditions. Yep.
And for our friends in Villa Grande, is there a reason they're not included on this analysis?
Oh, we kind of truncated just for purposes of our report. You know, we named each of the clusters, and I think we must have dropped the Villa Grande, but we will note that and we can fix that in the report.
Well, you're welcome, Rich and Kylo.
Yeah.
That was it. Thank you.
Building off of that, Todd asked what the orange and red polygons represent, or parcels.
Yeah, so the orange and red parcels are unaffected. That color coding reflects the original priority analysis that we did. We talked about at the last workshop how we identified priority clusters. So the red are the highest priority for connecting to a centralized system, the orange second highest. Those were the clusters that we prioritized. Yellow and then green would be the other color. So yellow are, you know, parcels that are generally outside of the floodplain and also not really that easy to get to. And then green are completely outside the floodplain and pretty remote for the most part.
Thank you. All right, any other clarifying questions for Catherine? Okay, well, as I mentioned, we'll have time to come back to all of this, but let's keep moving and talk about infrastructure and costs with unsewered communities.
Right. So just a quick overview of kind of the process that we went through. So in the last workshop, we talked about the community clusters and the prioritization process. So the first step was to go and really refine what those cluster boundaries are, because for us to assign cost to them, we need to decide, you know, exactly the number of parcels that are included in each cluster. So we refined the cluster boundaries, you know, drew the lines. I think if you recall before, we just had sort of circles showing locations. The second step is we took a look at what the unit cost would be for the community collection systems. If you guys recall the last workshop, we talked about looking at impacts to flooding and whether it's a pressurized system or a gravity system, as well as slopes and, you know, kind of parcels that are close together and further apart. So I'll talk a little bit about how we were able to incorporate that analysis. We use that information then to develop a cost for the cluster itself. These costs are common to all the alternatives, right? So the cost to build a centralized collection system within the cluster, as well as a discharge pump station that connects to the regional system. So we developed costs for each cluster. And then from there, we were able to calculate all the flows and loads from all the clusters. And we looked at each alternative and assigned clusters to where we would assume that flow would go, so that we could then determine what the additional treatment cost and the recycled water generated would be and the recycled water demands would be. And then we also looked at the cost and layout of the conveyance pipelines needed to get the flow to the wastewater treatment plants and from the wastewater treatment plants to the recycled water systems. So I'm going to go through each of these elements now. So next slide. This just shows the refined cluster boundaries. These numbers are slightly updated from what we had presented last time. You can see the cluster boundaries are now kind of more clearly demarcated, showing you know, what parcels, again, just for this study, we assumed were included. And just to, I think everybody understands this, but you know, these boundaries were drawn based on, you know, access to the road, what seemed logical based on wanting to capture Most of those red and orange parcels, which are labeled here at the low, medium, and high that we were talking about earlier, but also recognizing that, in practice, some parcels may not be excluded, other parcels may be added in. And the goal here was really just to be able to assign a cost for a reasonably sized group of homes in an area to connect to a central system. So don't want anybody to get wrapped around the axle about whether their parcel or a certain parcel is included or not. That was not the intent. Next slide. So this represents the total ESDs, flow, and loads that are contributed from the West County as well as the unsewered parcels. So you can see from a flow standpoint, it's about a doubling of flow, average flow. This is annual average, but more of a 50% increase in load and approximate 50% increase in ESDs. So basically the difference there is that, the loads and the number of connections is a little bit more than 50% more. But because the West County existing service areas tend to have higher inflow and infiltration than what would be expected from these newer collection systems, the flows contributed from the unsewered parcels are assumed to be lower per parcel. Next slide. So as I alluded to earlier, we took a look at kind of a range of costs for the collection systems within these community clusters. So there's really two sort of general categories: areas that are subject to flood risk and areas that are not subject to flood risk. So we use that flood analysis and the climate risk analysis that I talked about earlier to identify which of the community clusters have a significant amount of their parcels, about 30% or more, number of their parcels that would be subject to flooding. And for those that were identified as being subject to flooding, they were assigned cost per parcel for converting to a centralized system based on the numbers that were developed in the Monterey Villagrán report. And then for those that are not in that flood area, or there's just maybe a couple of parcels that are in the flood area that could maybe have their own little mini pressurized line, but the rest is gravity, we assume the gravity system would be acceptable. And West Jost recently completed a small septic to sewer project, but a similar sized cluster connecting a number of homes in a small neighborhood area to a centralized system, which is pretty similar to what we're talking about here. So when we were in the design phase of that, so we used the cost per parcel from that work to identify the cost for a gravity system. So not a huge difference in cost, but it is a little bit cheaper to go with a gravity system based on those data. The other factor we considered was slopes. So we had slope data for every parcel based on that was developed in the GIS database that Sonoma County had put together. And so we used the slope information as a surrogate to represent the parcels that are further up the hill, a little bit harder to get to, as well as maybe more spread apart because they're up in the hilly areas. And so what we did with that was in the Monterey report, they're based on phase 1 and phase 2. And if we look at the cost in the Monterey report for those two phases, there was a big difference. It was about $61,000 for the phase 1 per parcel, where those were parcels that were generally in the floodplain and down near the river and in the flat areas and fairly densely populated. But once we brought in phase 2 and we take that phase 2 cost and we looked at that, that was about $71,000 per parcel. So we used that differential developed from the Monterey report and applied that same differential to the gravity sewer cost to come up with that number. And then basically what we did was for each community cluster, we first decided if it was in the floodplain or not, and then we split the cost based on the percent of parcels that have flat slope versus not flat slope. So next slide. with that approach, we came up with a unique cost per parcel for each cluster. And then the total cost just for the collection system is shown here. And then we added to that another couple $1 million, depending on the flow, for the discharge pump station. So that represents just the cost to build the collection system within the cluster and the pump station to discharge into a regional pipeline, but it does not include the pipeline infrastructure to take it to the regional project. These costs, though, are common to all of the alternatives. So regardless of where the water's going, these costs would be required. Next slide. So I'm going to pause there because that was a lot of information, very specific to the clusters and how we identified costs for collection systems to the clusters and identify those clusters. So I want to pause there before we start diving into the alternatives to see if there's any questions.
Catherine, Kyle, I welcome you to talk a little bit more about the comment you put in the chat. I think this referred both to the previous presentation segment, but Catherine touched on some of this in the current one as well.
Thanks so much. So I had a couple of questions. There has been a lot of changes in FEMA changing what has been floodplain to floodway. And I'm wondering how that might impact properties as one question. And then my other question is, I noted that you said cost per parcel versus cost per units. And so I'm assuming that for multi-units, it would be a cost per parcel. Is that correct?
Yeah, so the analysis, the infrastructure required for when we're costing out the infrastructure. So that doesn't mean necessarily that parcel would pay that cost. That cost is what it would cost to build the infrastructure. So if there's a pipeline, for example, that cost covers removing an existing septic system, building a small pipe to connect where that septic system was to a centralized pipeline and then the pipeline down the street. So if there's, say, multiple homes all contributing to one septic system, the cost to connect all those homes is still the same as it would be if there was a single home. So for identifying the cost to build the collection system, that's what we use. Later on in the presentation, we're going to talk about what these costs are per ESD. So total cost per ESD. So we did have some limited information where, say, multifamily homes or something were identified on a parcel that would have multiple quote unquote ESDs on that property. Then those costs per ESD would be different because those costs per ESD reflect the centralized treatment system, the pump stations, all of the infrastructure needed to support the wastewater, which is based on flow generated, not just a pipe XYZ size, if that makes sense. And again, this is all very high level, just trying to get to numbers that should provide us a reasonable estimate of what this kind of thing would cost, not trying to define a procedure of how costs would be allocated in any kind of future condition.
Thank you. I also had a question about the flood plain and turning into the floodway for certain homes.
Oh yeah. So a flood in a floodway, what that means generally, and actually you flip back to the figures, we show the floodway on the figure. So you scroll back a couple of slides. So in a floodway, you cannot construct go back a few more slides. Keep going. Yeah, okay. So the red slashed here is the floodway, and then the blue is the floodplain, and then the orange is the 500-year floodplain. So the floodway, what that means is you cannot construct any infrastructure, vertical infrastructure in there that would impede the flow of water in that area. So that would need to be, from the standpoint of the type of infrastructure we're talking about, pipes in the ground, pump stations, those should not be impacted by the floodway. If we were talking about building a treatment plant or a big home or something like that, those could be prohibited in the floodway. But any of the infrastructure we're talking about here is all subsurface and shouldn't be impacted by that designation.
Thank you very much.
You're welcome.
All right, there's also a hand up from Steve.
Yeah, I want to get my audio. So just a quick question on, because we ran into this last time. When you're saying the per parcel cost, is that the per parcel cost for the public infrastructure to get to the parcel? Or does it include, let's say in the case of those that are in non-gravity fed areas, the cost of replacing the existing septic with a grinder pump and whatever that system, and a storage tank in the case of flooding, all that stuff, those of us that live in the way or the plain would need to do.
Yeah, so if you go back one slide, please, Sam. So so the $61,000 per parcel. What that is the cost that was developed for the Monterey Villa Grande study, which included grinder pumps and all the infrastructure associated with that, divided by the number of parcels in the phase 1 part of that work.
Okay.
The 71,000 is the same approach. So the additional amount for phase 2 divided by the number of parcels there. So it included all the same infrastructure assumptions that were applied in that study. For the top two numbers where a gravity system would be, it was the same approach where we took the total cost from a similar project and divided that by the number of parcels that project was serving to come up with those numbers. So these include removal of the septic tank, and for the pressure systems, it includes the grinder pumps and the pressure systems, and all that.
Okay, and just as another point, there are a number of members of the Citizens Advisory Group on this call, and we have not seen a final report. I assume you're referring, when you say Monterey report, you mean the Monterey Villa Grande feasibility study?
Correct, the September 2024.
On phase 2 in the latest version in the September 24 report that we saw.
Yeah, correct.
So if you've got,
so that was the latest information we had on that.
So where did you get phase 1 and phase 2 from?
Those are described in the report.
Okay, I'll have to go back and look at it. Thank you.
Yeah, this group had pointed out to us that information was in there, so we went and looked for it and found it.
Okay.
Hand up from Rich.
Yeah, so you're showing higher costs for hillside parcels than for flat parcels. And I'm wondering how that gets addressed in actuality. Would those costs be distributed across everybody regardless of whether on a hillside or a flat, or do you envision that the hillside people would somehow be assessed more than the people on the flat?
That is way beyond what this study would look at. What we were trying to define is what is the cost of the infrastructure, not how it would be distributed to the customers. So I think each cluster, depending on how these projects move forward, would have to define that.
So the actual cost to somebody on a flat parcel could be 5 or 10% higher, it looks like.
I mean, typically, that's not how it works. Typically a wastewater agency will assign costs just based on the flow discharge. They don't take into account how hard it is. But I think, again, Monterey Villa Grande, as they move forward with their project, are going to need to figure out how they're going to pay for the infrastructure required. So our effort was really just to say, recognizing that these factors, being in a floodplain, not being in a floodplain, being on a hill and spread out and not being on a hill, affect the cost of the infrastructure. So we need to define the cost of the infrastructure. So we incorporated the information we had available to be able to come up with what we think is a reasonable total cost. And that's really what we're focused on here, which is the next slide, is what is that total cost for to build a collection system for these parcels. And so we just wanted to use the information we had available to us, the slope information and the flood information, to be able to come up with the best estimate possible for what this infrastructure might cost.
Okay, I got you. That makes more sense.
Catherine and team, I think it seems a little, I understand the point of breaking it down by parcel, but the way it's labeled, clearly there's some confusion about it being an assigned cost per parcel when in actuality, I think what you're trying to show is like, how the cost could potentially be distributed across the collection area without additional funding being available for that work to happen, right? I mean, I caution the team on labeling it as cost per parcel when there's not really the point isn't to assess a parcel for that amount of money. Do you know what I mean?
Yeah. I totally hear what you're saying, and maybe we can think of a better way to phrase it. I think for us, everything was looked on a per parcel basis because that's what we
I
had
totally get it. Like
yeah,
like that makes sense to me. I'm just it's a just a naming situation. I think it's just
I
a labeling
totally get what
thing
you're
for
saying.
clarity.
100%.
Yeah.
Yep. Totally. And we can think about that maybe as we work towards getting this report ready for the regional board, how to maybe reword that in a way that it isn't misinterpreted.
One more question, then we'll keep moving through the presentation. Steve.
Just a quick follow-up on that brief conversation you guys had. It seems like what you're doing is you're using a per parcel average to create, for math purposes, to create the cost, not to assign cost to parcels. Right?
Correct.
So
that's right.
I would be clear about that. And that it's a math exercise to get to a number. It's not a way to get to a number for an individual parcel owner.
Right. That's right. We do have some numbers later on, and I alluded to this, where we do try to assign a cost, but in that case, we're talking about cost per ESD, per equivalent dwelling unit. I don't actually sure what ESD stands for, but anyway, and that's when we say, okay, here's the total cost for everything, the collection system, the conveyance system, the treatment, all of those costs. And if we take that total number and divide it by how many equivalent units are in that cluster, we can define a cost per connection or ESD. And then, right, a commercial entity, for example, might be 5 ESDs. An individual home is 1 ESD, right? So you could start to kind of think about it. And again, that is being done only to give a sense of, what are we talking about here? Because these numbers get really big when we start adding them all up, and then we divide them back out to see what that means per home. So we'll get to that in a little bit. So we should move on. All right, next slide. So just
sorry, real quickly, just for everybody's edification, ESD stands for
equivalent single family dwelling.
Thank you. All right.
Single family dwelling. All right. So alternative 1A involves, the 2 local treatment plants, one being at the Russian River Treatment Plant and the other a combined facility that is the Forestville Grayton facility. In terms of the clusters that would be connected, the assumption is clusters 1, 2, and 3, and 12. Which is the Montegrio Villa Grande area, and then we've got the Northwood, and then the other 2 areas that are south of Guerneville would all be connected into the Russian River plant. The remaining clusters, so 4 through 8, all come into the Forestville plant, and then 9, 10, and 11 come into the Grayton plant. And then just to remind everyone, the connection between Occidental and Grayton is already being planned and developed as a separate project. So we do not have the cost of that infrastructure built into this analysis. But what we have done is looked at if it had to be increased in size to accommodate cluster 11 or cluster 10, what those additional costs would be. Next slide. So at the Russian River treatment plant, there are some, fairly substantial condition-related improvements. I mean, these are just, typical wastewater treatment plant equipment reaches the end of its useful life. It has to be replaced. We also determined that in order to accommodate the flows that would be coming in with the additional clusters, that one additional filter unit would be required. And then there's some minor expansion to some of the hydraulic conveyances. So a pipe needs to be upsized or a parallel pipe needs to be put in to be able to convey the hydraulic flows. But overall, the treatment plant should be able to provide capacity for the clusters that were shown with fairly modest cost. Next slide. So as I mentioned earlier, when we looked at the recycled water availability or the demands in the area, there really were not a lot. With the additional clusters, about 555 acres of additional land application area would be needed. And, the Sonoma Water, Russian River CSD has recently gone into a deal to purchase this additional 400-acre wooded parcel around the treatment plant, which extends the red boundary is kind of the existing area and the black is the new area. And so the assumption is that within this area that 55 acres could be identified. And, maybe there could be some expansion of municipal reuse also incorporated, but pretty limited opportunity for that. So most of the emphasis would probably have to be within the wooded area. Next slide. So at the Forestville treatment plant, just to remind everyone, there would be pond-based treatment. Both Forestville and Grayton provide pond systems that treat to what we call secondary treatment standards. We previously talked about that the Grayton system would have to be upgraded to a fully mixed aerated system to treat all of the loads that would be coming in from Occidental. And so adding in a few more clusters could still be accommodated with that. But now adding an additional flow of Forestville would require an upgrade to that pond system as well to get more treatment out of the ponds. Both plants would produce a secondary quality of effluent. They would come here then to the Forestville plant where they would be treated through a filtration and disinfection process. And so space is limited at the Forestville plant. We're assuming the existing pond that's kind of located on the western side there would be filled in, and that's where the new treatment facilities would be constructed. And then from there, the water could be distributed back into the recycled water system that is already managed by Forestville and Grayton. Next slide. So here's where the real clincher is. So, as we talked about in the analysis, we determined that most of the land available for recycled water distribution is vineyards. And so if we apply the vineyard demands of the current vineyards that Forestville and Grayton discharge to, there would need to be about 3,000 acres of vineyards brought online. So while that 3,000 acres could be reduced, though there's a few orange parcels that are pasture in there, and if you brought those online, maybe you wouldn't need all 3,000 acres, but you would need a very substantial recycled water distribution system for this alternative. And I want to remind everyone that probably don't remember this, but the Forestville and Grayton facilities are both facing a need to upgrade their treatment plants for nitrogen removal. And so this alternative, they requested it to be focused around eliminating surface water discharge. So the analysis took a look at what kind of recycled water, how much land would we need? Could we go to zero discharge so that we could just continue to have our pond treatment and not have to go to that level of nutrient removal. And what this found was you could do that, but because of the limited demands of the area, the amount of recycled water system and the amount of storage you would need, about 620 acre feet, makes this fairly expensive approach to managing the flows within the system. Next slide. So now let's go to alternative 1C. And we'll visit the cost after I go through all the alternatives and remind everybody what they are. So 1C, this was the one facility at the Forestville treatment plant that is designed for nitrogen removal, so it allows for surface water discharge. We've got a similar approach where clusters 1, 2, 3, and 12, they go first to the Russian River plant where they get combined with flows from the Russian River facility and then pumped over to Forestville. The pipe alignment would go along River Road so that clusters 4 through 8 could be picked up along the way. And then we have 9, 10, and 11 coming into the Grayton plant. Similar scenario, they would come into the plant, combined with Grayton flows, and then discharge to Forestville. So everything then comes into the Forestville site. Next slide. So under this scenario, there would be what's called a membrane bioreactor treatment plant that would be built to provide the water quality needed both for discharge to Russian River as well as for reuse, unrestricted reuse. We'd also now have an activated sludge plant, which means we'd be generating solids that would have to be treated. And so for this, we've assumed that some aerobic digesters would be dewatering. The other thing to point out is that one, there would be discharge to the Russian River. There'd be a new outfall to the Russian River from the Forestville plant because the current discharge locations for Grayton and Forestville are smaller creeks and you wouldn't be able to get the 100-to-1 dilution needed. The other thing to point out is that the infrastructure at Russian River, Grayton, and Forestville, those existing ponds, those would be used to equalize flows. So we talked about how those collection systems have fairly high infiltration and inflow. So we would take advantage of the fact that each of those treatment plants have some ponds, have equalization capacity, and that basically helps keep the cost of this centralized treatment infrastructure lower than it would otherwise be by equalizing. So we also have that built into this alternative. Next slide. So there would, under this scenario with the winter discharge, we have incorporated the quarries as shown by the yellow pipeline here. And then you can see also the green pipeline that goes up to the discharge to the Russian River from the Forestville plant and the existing recycled water users. But other than the quarries, we would not need to bring any additional new recycled water users online, except for some modest expansions for the existing users within Forestville. But we would need some additional storage, and we've assumed that that could be constructed on the 21 acres of land that is adjacent to the existing Grayton storage ponds. Next slide. So those were the two local treatment scenarios. Then we have the export to Windsor scenario that we previously defined. Next slide. So this is pretty straightforward, fairly similar to the Forestville scenario where clusters 1, 2, 3, and 12 are brought to the Russian River plant and the pump station there combined with equalized Russian River flows, pumped into a pipeline that goes along River Road that picks up clusters 4 through 7 and then brings that up to the Windsor plant. Then clusters 10 and 11 come into the Grayton plant and 8 and 9 into the Forestville plant, where there would be a pump station combined with those flows, which are pumped into that big force main. So pretty significant conveyance system here. All treatment would be at the Windsor treatment plant, and there'd be a fairly substantial connection fee for providing that treatment. Effectively, Windsor has formed the team that effectively there would be a need to build all of the treatment to treat these flows. So under this alternative, you are paying to build a treatment system at Windsor in addition to paying for all of this conveyance infrastructure. Next slide. Oh, and I guess I will note on that, we also, for this alternative, do look at bringing that recycled water back, and that's incorporating the costs that we're going to show later. For Santa Rosa, pretty similar to the Windsor, just a different location where the water goes. Same approach with having a Russian River, Forestville, and Grayton plant that accept flows from the clusters and then pump it from a centralized pump station into the force main out to the Russian River plant, the Laguna plant. And we did identify a potential connection point into one of the trunk lines of the Laguna plant, so we wouldn't have to take it all the way to the treatment plant, which is shown here. And similar to the Windsor, the connection fee for Santa Rosa would be pretty substantial, pretty much on par with what it would cost to construct a whole new treatment plant. So under this approach, you are paying for treatment, building new treatment facilities, as well as the infrastructure needed to convey the flow out to those treatment facilities. Next slide. So 3B was just a combination scenario, thinking about the flows north of the river going out to Windsor, and then still having that local Forestville Grayton plant for the flows that are south of the river. So the next slide, and just incorporates elements from the previous work. So in this scenario, we're assuming clusters 1 through 7 plus the 12 would all go out to the Windsor plant, and then clusters 8, 9, 10, and 11 would be treated at the local facility. Next slide. The treatment at Forestville is exactly like what we talked about under alternative 1A. It's just the facilities are a little bit smaller because we're not treating all of the flow, but the same concept of having 2 different pond-based treatment plants with the filtration and disinfection at the Forestville site. Next slide. And with less flows, there is less expansion area needed, but it's still a pretty significant storage amount, about 420 acre-feet of recycled water storage. And sorry, the number didn't up and up here, but it's about 1,000 acres of land application area. So we also note that for this approach, because this recycled water system would be so substantial and you would need all of this just to dispose of the water that was generated within this area, you would not be able to bring other flow back from back from Windsor into this, because this system would be maxed out. So there's really, this kind of eliminates that opportunity to return those flows that were exported to Windsor. Next slide. Okay, so with that, I'm going to pause. So you guys, if you want to ask any questions about these alternatives, I know we've talked about them before, so I went through them fairly quickly, but I know that that was also some time ago. So happy to try to refresh anyone's memory if there's things that you don't recall.
Thanks, Catherine. I would point before we open it up for other questions, there's a few points in the chat. I don't know if you want to read those and see if there's anything that jumps out at you.
Yeah, let me see here. So yeah, maybe let me scroll up a little bit. I'm not sure where there's a few in here. Okay. Oh yeah, we talked about the orange and red. We talked about the floodway. Yes, the connection, Charles. Okay. Oh, we did want to point out that sorry about that, I misspoke. It wasn't a purchase of the acreage. The lands were transferred. Thank you for clarifying that. we do have the alternative for what to going to Windsor. In terms of going to the geysers, Windsor has limited capacity in the pipeline that goes to the geysers. So it would not likely be feasible even if they were to accept flow from West County for that flow to actually be used in the geysers, unless Calpine, invested in some more conveyance infrastructure to bring more water up there, which I understand is on the table, but and maybe would need to be brought into some of these discussions in the future. But for now, they indicated that they have very limited ability for recycled water discharge, and they felt like they would probably need to bring water back to West County if they were to accept flows. It's recycled water demand for the quarries. Yeah, I can pull that number up. Give me a second to do that. And then the existing trunk lines. Are you talking about the trunk lines in the collection systems of the existing?
The Santa Rosa tie-in for that alternative.
Yeah, so that's our understanding. We to be clear, like we took a look at the Santa Rosa collection system master plan and identified the existing trunk that could likely accommodate the flow. They did indicate that when we talked to Santa Rosa, they were not 100% sure that trunk line would be big enough, but they felt it was a reasonable approach for this purpose of this study.
So so the alternative is it could be more expensive than what's being estimated for that option.
It could be more expensive.
Yeah,
exactly.
yeah.
This is probably the least it could be. So for the quarries, there's about 26.5 million gallons per year of recycled water that could be used by the Canyon Rock Quarry. That quarry is the one that receives potable water. The Bodine Quarry uses significantly less water. They just have different processes. So it's more about, they're less than 1 million gallons a year. But we did incorporate them because they're literally across the street from the Canyon Rock. And so if you're building a pipeline out there, you might as well offer recycled water to the neighbor. I'm also thinking that if they had recycled water available, maybe they would, do different types of things if they had more water available. So I think, we really just did a very high level look at like, what are these quarry demands? And, is it worth, putting an investment there? And I think because of the storage they provide and the year-round reuse, the answer is yes.
Thank you.
All right. Any other questions? All right, let's get to the good stuff. Next slide. All right, here's the costs. So we attempted to, we took the total costs. This is the capital cost, which includes, all the project costs, implementation, everything. So starting from today all the way till it's implemented, everything that would be costed. And we did split those costs out amongst the agencies and the unserved communities based on the amount of capacity that would be used. So we looked at, treatment capacity, conveyance capacity, flows and loads from each section and said, this is how much would be used under these different alternatives. The other thing that we did was we assumed that the unsewered communities would also be paying a connection fee to under alternative 1A. They would be paying a connection fee either to Russian River or to Graydon and Forestville based on their current connection fee structure because of the use of the infrastructure that's already there that they would be able to take advantage of, right? Because they don't have to build all new things to accommodate these flows. The unserved communities would have to pay in for some of that existing infrastructure. And that's common anytime you connect to the wastewater treatment plant. So that's sort of how we broke out the cost. Each cost element, there's a lot of detail in the report how we got to these numbers. This is just the boiled down. The 20-year present worth operating costs, this is additional operating costs beyond what is already operating costs. So this is what new. And so, for example, under alternative 1C, you see the 20-year cost is very low. That is because we're assuming we are taking 3 different treatment plants offline and building 1 new treatment plant. So we get a lot of economy of scale on operating staff, chemical usage, all of that when we consolidate all of our treatment into one place, and we eliminate a lot of the overhead and everything at the other facilities. So it doesn't cost $4 million to run an MBR plant, but the differential between what it costs now, what you wouldn't have to pay now, is about $4 million. You can see that the alternatives that involve export are significantly more expensive. This gets back to what we were discussing about, or what I mentioned a couple times about, the connection fees to Windsor and Santa Rosa are effectively the same cost as building a new treatment plant. So once you add that and the cost to convey the water there, it becomes a very expensive alternative. So unless, that could be negotiated down somehow, the sheer difference of a couple $100 million probably points us towards keeping wastewater local. I do want to point out that for the unsewered communities, there's not a huge variability in cost, as compared to, say, the local facilities. And a lot of that has to do with the fact that a big chunk of that baseline cost is building your own collection system, building the pipeline that gets the flow to the location. And it looks, you could interpret, one might look at this data and say, hey, for the unsewered communities, it's kind of the same cost whether we go to Windsor or not. But that's not accurate, because the cost for the pipeline to get to Windsor is much cheaper for the unsewered communities when the Russian River or the community is paying for half of it, right? When the existing sewer folks are paying for half of it. If the unsewered communities built their own pipeline, the cost would skyrocket because there's not that economy of scale. So don't get fooled into looking at these individual line items and think, hey, for unsewered, we could do any of these things and it'd be the same cost. It won't pencil out that way. So the final thing to point out here is we have kind of the second line where we have it's 715 million to export to Windsor or Laguna treatment plant. If we added in those costs to bring the recycled water back, those would go to the 730, 742 number. So that's what that adder would be. We wanted to show that as a separate line item, since that element may not be required, and it's sort of a nice to have, but is it essential to have, is not 100% clear. I'll pause here because this is a lot of information on one slide, and I know the cost always are get people thinking. All right. Not seeing any hands up. We'll move to the next slide. So this is what I was referring to about looking at the cost per ESD. So this is just to give a sense of okay, for each ESD, what would this be? These numbers are helpful to, I think, for a couple of reasons. One is, the state funding for septic to sewer has a cap per ESD that they assign. So this kind of tells us how close we are potentially to these cap numbers. The other thing kind of point out is, depending on the alternative and where you're located, the cost per ESD is either higher or lower. So, under alternative 1A, the cost per ESD for clusters 1 through 4 and 12 is fairly low because you're pretty close to the Russian River plant. You're not taking the water too far. But that increases a lot if you start to have to pump the water all the way down River Road. So you can see the variability for each parcel is really more closely tied to how close you are to the infrastructure that you're trying to get to. But overall, if you take a flow weighted average of these numbers, which is the bottom row there, it's all pretty much the same, which kind of speaks to the last slide, which is the costs are, a lot of the cost here, the base cost is that centralized new collection system and the pump station and everything to get the water out there. Next slide. So I wanted to talk a little bit because there were some comments that we got early on, and I wanted to be responsive to this about, okay, well, that's capital costs. Maybe we could get grant money to pay for some of that. But what am I going to have to pay every year for this service? So we wanted to try to quantify that. Now, so this is just operating costs. So I have to be clear about this. These numbers do not include any debt service for any of this new infrastructure. So that, this would be an ideal world where 100% of the infrastructure is paid by grants. But this is just an example of the procedure I went through because I think it's important for you guys to understand. So if we look at the first row here, so this is for alternative 1A. So we look at the current annual O&M cost. So Russian River CSD total current annual O&M cost for the treatment plant operation is about $5.5 million. So that cost would now be split amongst the existing Russian River customers and the new Russian River customers. Then the next row shows the additional O&M costs, which isn't very much at the Russian River plant. Because like I said, there's not a lot more stuff needed to treat the additional flow. That gets split between the existing customers, the new customers as well. So because those two costs get added together and they get distributed. So that's how we look at the plant operating cost. We have a similar approach that we apply for the Grayton plant. Then we look at the collection system and we say, okay, Guerneville has its own, Russian River CSD has its own collection system. It's only being served by those members. So those members pay that amount. Only those members pay that amount, not the unserved communities. Same thing with Forestville and Grayton. Forestville and Grayton pay for their own collection systems. And then the final line is the estimate of the collection system O&M. And we also developed that using the information from the Monte Rio study. There were some costs for operating the pressurized system. And then we added to that the assumption that each cluster would have 2 full-time employees that manage the systems, maintain them, and do all of that. That's a pretty conservative assumption. And the big green box on the bottom is saying, hey, if each of these clusters tried to go at it on their own and had to hire their own staff to manage their system, it's a lot more expensive than if they could be a collective group of people, maybe a JPA amongst these. Who knows what that structure looks like? But if those staffing resources, those management resources for all of these collection systems could be somehow combined, you could save a lot of money in those costs. So we were pretty conservative on that. We add all those up and then we divide that by the number of ESDs, and then that tells us the cost per ESD estimated for this alternative. And if we go to the next slide, we have the numbers we calculated for all of the alternatives. So what this tells me, what this analysis tells us is a few things. One, alternative 1C, you can see with that one centralized treatment plant in Forestville is probably the lowest overall cost because it's one treatment plant. And all of those staffing resources are a very significant part of operating costs for any utility. And so when you combine those into one place, you do get a lot of savings. So you get the overall savings by having that one treatment plant. But again, those capital costs are much higher to be able to provide that, or potentially much higher. 1A has some pretty high numbers, and a lot of that has to do with having to add a bunch of staff to operate that very large recycled water system. Then if we look at 2A, the export options, those are for the unserved communities, those would be the most expensive options because of the operating costs that you'd be paying to Windsor and Laguna, in addition to the cost to manage and operate all of those, your collection system and all those systems. And then 3B is kind of a hybrid between those two. So I'm going to pause there and take a moment to answer some questions.
Any questions for Catherine before we move on?
All right, you guys are probably overwhelmed.
Can I just flag Kyla's comment in the box, in the chat box here about and Kyla, I hope you don't mind if I speak for you really quickly, but the issue being the construction costs and the partial reassessment on the property could lead to greater property taxes over time. And it's worth noting that isn't accounted for in these estimates. And I don't, not unlike our previous conversation about improving the existing collection system in Guerneville, it would occur across the board anyway. So I think, I understand maybe why it wouldn't be included here, but I wanted to flag it as something that is worth considering when we're, when we're looking at the cost per ESD, because it won't be insignificant if in fact it happens.
All right, let's go to the next slide. So we did, similar to the previous work, we did a qualitative ranking, and there's detail in the report on how we came up with these numbers. I don't want to get bogged down in that, but we did look at the alternatives again through the lens of, now we have these unsewered communities, so the infrastructure changed, some of the qualitative criteria has changed. So we did readjust the ranking based on that. And then the next slide shows the results of the analysis. Combining the cost and the ranking, alternative 1C comes out to be the best option. But there's a big but there. If alternative 1A, which is the 2 local facilities, did not assume zero surface water discharge and instead assumed Russian River discharge, the qualitative ranking would be very close to, very similar to 1C, and the cost would likely be less. So we are recommending that both 1A and 1C be thought about more. And in fact, it's very likely that maintaining 2 different facilities is going to be the lowest cost option. And we recommend that to be prioritized moving forward. I think one way to look at it would be a new facility. If we look at 1A, 2 local facilities, but where the facility at the Grayton Forestville plant is more that surface water discharge, that NBR treatment plant, that's sized to serve the local communities, that could more easily be expanded. And over time, if it determined, 20 years from now, that connecting Russian River over there, you could bring that into that type of facility. If you went with zero discharge, just keep adding more and more reuse, it just becomes more and more impossible to just expand. So a 1C or a modified 1A are kind of the 2 strategies that really rise to the top as being the right way to sort of manage West County flows through this analysis. Next slide. So looking at and going back, and maybe can you go back like 2 or 3 slides to the cost estimates? Keep going. One more. Okay. So looking here. Okay. So for Russian River treatment plant, under 1A, it's a $9 million cost. Under 1C, it's $199 million cost. Most of that cost is that conveyance to get the flow over to the Forestville plant and to build and to support building that whole new treatment plant. So for Russian River, it makes sense to keep local. It doesn't make sense to spend $190 million when you have a treatment plant that is in pretty good shape. Yes, it needs some condition-related improvements, but it provides nitrogen removal. It provides Title 22 filtration and disinfection. It's a state-of-the-art treatment plant. It does not make sense to abandon that facility. Now let's take a look at Grayton and Forestville approaches. Again, for the Grayton Forestville plant, it is less expensive to do 1C, to build that central treatment plant, than it is to go to zero discharge. And that's directly a result of finding that there's not a lot of reuse opportunity in the area, and you'd have to build a big, large system out to a bunch of vineyards in order to dispose of all that water. So that's why we're saying this modified 1A, where we look at Russian River, but then instead of a zero discharge for the Great Forestville plant, we look more at that surface water discharge approach. So now you can go forward. So for Russian River, again, remain local. You've invested in significant treatment infrastructure. The treatment plant's in good shape. The facility can accommodate more users. The unsewered communities that we identified can generally be accommodated within that treatment plant. There's a filtration expansion needed, but that's a pretty modest cost. This is definitely going to be the most cost-effective strategy for this region, for the area around Burnville, Monterey, Villa Grande, Northwood. Treating at Russian River is going to be the lowest cost approach. Next slide. For the Graytonville Forestville, it's likely continued surface water discharge. This definitely needs to be looked at some further. I mean, there is economy of scale when you build a treatment plant that accommodates all those other users, but moving towards, we would recommend that as Forestville and Grayton look at what they're going to need to comply with these permits, that they consider upgrading the treatment plant to, sorry, my daughter isn't here. She just got home from school and she just got a new puppy. So she's out now. Distracting. Anyway, for Forestville and for Grayton, zero discharge probably is not going to be the best strategy for meeting these nutrient limits, and that we do recommend that additional evaluation of this combined treatment approach to achieve nutrient removal is probably going to not only be the lowest cost, but it also gives the best flexibility for that treatment plant to bring in unsewered communities over time. And that as flows increase, eventually this treatment plant will need to discharge to the Russian River, but that's something that needs to be looked at and would be implemented over time. This is the last slide. So with that, open to more questions.
Right. I do see a hand up from Steve. Steve, you want to start us off?
Yeah, this is similar to what Kyla brings up. I mean, and it may or may not be incorporated in your potential charges per ESD, but there are a significant number of charges in terms of a one-time capacity charge by Sonoma Water in the case of the CSDs, and then also a significant number of charges from Permit Sonoma for permitting the new systems once they go in. Are those costs being included in your estimates? Because they can be significant.
The connection to the treatment plants is incorporated. The costs from Permit Sonoma, that would be, again, that's kind of a detail. I believe the costs for again, that kind of goes back to, were the collection system costs included in the Monterey Villa Grande? We do include on all of our cost estimates, we calculate the capital cost, which is the construction cost, and then we add 25% for engineering, legal, admin, permitting. So those dollars are in there. They get distributed to all the customers that take advantage of the infrastructure. And so, yes, all of those costs should be in there.
Including
those are in those capital costs. Those are in those numbers. Go back a couple of slides.
Including the recently proposed increases to the one-time capacity fees by Sonoma Water?
Go back down one slide. Yeah. So these costs per ESD, this is the one-time cost. Now, getting down to the detail of, I'm not exactly sure, Steve, what fee you're talking about, but I think what we have built in here is the identified connection cost for Sonoma Water for the connecting to the Russian River plant, the one-time fee. We've incorporated into this all of the infrastructure needed to construct connecting to the plant and the portion of the expansion of treatment that would be taken up by the new users. And we've incorporated into that what we call legal, administrative, and like permitting environmental fees. So, which is just a multiplier. So presumably that multiplier, you know, should account for those other like environmental fees, you know, permit fees, that type of thing. So, you know, this level, you know, we're looking at pretty high level, but we're talking about, you know, $120,000 per ESD, one-time cost to pay for the project. The other slide, the annual fee, that would be just the operating cost. So the $120,000 per connection, typically the way these things are paid for, obviously there's grant money, but if infrastructure is built, you know, you take out a bond and a loan for that. So those annual rates, the $2,000 a year, maybe $1,000 a year, and you're paying off the cost of some of that infrastructure. So some of these costs that are shown here, which are the capital costs, the construction costs, project costs, some of that might be paid up front, some of that might be paid over time. The annual costs that I showed, those are just the ongoing operating costs. They don't account for any of like debt service. So if you took out a loan to pay for some of these upfront costs, you'd have to pay that over time. Does that help?
It helps. I just want just be sensitive to the fact that I think there's some hidden consumer costs that are in the infrastructure within state and county government that come into play when your house enters a different class. So
yeah.
So, you know, if my home is reassessed, that's not a one-time cost. That's an annual increase in my property taxes.
Right.
If it's reassessed, there's a capacity charge from Sonoma Water to do anything. And I don't know if those charge costs are in here, and don't know what those new proposed capacity charges, what happened to them. They were proposed in May, and I don't know what happened. The other is that there are a significant number of permitting costs to do any work on my property that may or may not be included in all of this. And one could say, if the county's doing the work, all that's taken care of. Or one could say, we forgot to think about that. So I'm helping you have those discussions before we get, you know, to one of these solutions, because it could be significant per homeowner or per property owner. Or
yeah, and I think Steve, the thing that maybe for everyone to appreciate here is you know, our goal here is to provide a tool to the county to say, hey, if I need to go out and get funding, how much money do I need to get? Right. If I'm going to implement and help implement an alternative, what does that look like? Every single one of these communities would have to do their own study to identify what their costs are and what it would look like as part of some kind of future effort. So I'm not trying to say, this is your cost, write it down forever, this is it. This is just saying, hey, here's kind of your picture, feasibility level of what this might look like. Do you want to take this forward now and continue to look at this? Or do these numbers scare you so much that you're going to say, no way, right? And Steve, 100%, all the things you're talking about need to be worked through, but that is like definitely a next stage of work.
I mean, I think we need to scare them all the way. I mean, really look at what the costs are going to be. Oh, no. We're not going to talk about those things because they'll get passed on to individuals in the community if they're not taken care of early on. In other words, if up front we don't deal with this property tax thing, it's going to go on to people. If up front we don't say permit Sonoma's costs for inspecting all these properties and issuing permits to put in their pumps or do whatever they need to do is covered in this cost. If we don't say the capacity charges for sewer connection are covered in these costs, then that's at least 3 that I can identify. That
Well, Steve, I think 2 of the 3 that you just said included in these costs. So permitting costs are included in these costs.
Okay.
And connection fee to Sonoma Water Treatment Plant are included in these costs.
Okay.
Increasing property tax is not included in this cost because I don't know how to estimate that, nor is that really within the scope of what this is. But I think that could be something that could be noted for sure. You know, I think it was brought up earlier. We could add a note here that says, hey, as a result of this project, the cost to homeowners' property taxes could go up. And we can acknowledge that, but I don't think this is an engineering study. I don't think we're the capability to know or to say what that would be.
It would be helpful if you did that. I mean, we
Yeah.
did this issue 5 years ago, and again 2 years ago, and again 6 months ago, and we haven't been able to come to what the solution is in order to do that.
Right.
So
yeah, it sounds like a tough issue. I hear what you're saying. Yeah. It's a yeah. And I think it's important to acknowledge it. It's kind of just beyond the scope of this engineering evaluation.
Yeah. And you're right. It'd be fair to note that home values might go up as well. But
some people might like that, but
you tend to live there forever.
Right. So for the remainder of the session today, we really wanted to just get any additional feedback or concerns you have about the regionalization alternatives. So no more slides, but I do see Rich's hand up. Let me go to Rich.
Yeah, I think it's pretty apparent from the discussion that the way the costs are presented is pretty confusing. And that one table for ESDs where it gives it as a fraction of $1 million is not how most people think. You know, 1/10 of a million is $100,000. You know, that $100,000 would be more understandable to the average person. But I think you need to break it down into, you know, a clear delineation of these are what the upfront costs are, assuming this table here is all the upfront costs. But as Steve said, we should have a breakdown to see that everything's actually included in there. And then on the O&M costs, that's more of a wild card because you still don't know what kind of governance structure you're using. But similarly, it should be said that this is a reasonable expectation of what it's going to cost you per year, with all the caveats that have been stated. It would make it a lot clearer, especially when you have to flip from one page to another and, you know, see, you know, how much is this whole thing supposed to cost.
And Rich, and I think I'm sure you appreciate this. I mean, there's a 300-page report that this slides present, you know. So we're trying to boil down a lot of information into, you know, something that could be presented in less than an hour to a diverse group of people. So there's a lot of caveats to all of these numbers. That is fairly well documented in the report. But I hear what you're saying as well. And as we work to finalize the report over the next, you know, couple weeks, I'll make sure, you know, we'll take a look and like kind of make sure that we are, you know, clearly saying the things that you guys are hearing. And then when you get a chance to review the report, we'll be looking for that feedback, right? How we adequately characterize these caveats. And I think that's the right time. I mean, not that we don't take comment again, we can incorporate it now, but I think once you see the report, you see the level of detail and that goes into how we got to these numbers. Hopefully you'll appreciate that it's not just a simple table of like, here's the cost.
And one other comment is there's a lot of costs involved in connecting to a system besides just the permitting costs. A lot of times people might have to, cut through a driveway to lay the pipe out to the street. Or, we had cases in Guerneville where they actually had to, the property was so steep, they had to do an above ground pipe of ductile iron, which was very expensive. And I don't know how those can be considered, but hopefully the estimates are broad enough that people don't get caught blindsided. And then on the grinder pump systems, it's most likely that most of the existing septic tanks cannot be used as a pump chamber just due to age and deterioration. And also, there could be a substantial number of houses where the electrical system may not be able to accommodate the pump without upgrades to the panel. So these are just a lot of little costs that add up for the property owner when they go in to hook up to the system, and probably would actually, although the permitting costs, need to be considered. I mean, those little incidental costs could be way more than the permitting costs. So it seemed like you may want to give a range, like a easy connection versus hard connection or something. And
yeah, I mean, I think that's what we attempted to do earlier in the presentation with those per parcel numbers. That's exactly what we were trying to do, was to reflect that. But I think, yeah, there's, maybe the way to look at this is all of these numbers we're talking about here are probably plus or minus 50%. We are very high level cost estimating at this stage.
Yeah.
And that's just how it is, a feasibility study. The other thing is that we really, if you think about this, our focus was more about the treatment infrastructure and getting the flow to a treatment system. We really did not, the level of detail we looked at for those clusters was very minimal. We wanted to come up with something we thought was a reasonable number, but the focus of the study was more about the centralized treatment system and the main centralized infrastructure, what that's going to take. The thought is that each of these clusters is going to have to do their own work to figure out and answer those questions that you're talking about, Rich, because that wasn't the focus of the study. So and I think that's a very great point that, just thinking about my recommendations at the end of the report, that, that needs to be clearly shown that like these clusters need to invest in really identifying the true cost of building collection systems, as well as what they're, if they want to move in this direction, right? They need that investment needs to be made, that those costs need to be better defined. That's a big focus that needs to happen. But what we were trying to do here was more say, hey, Grayton and Forestville, you guys have, some things that you need to do at your treatment plant. And if you move in this direction instead of that direction, you're going to have more flexibility to take in these unsewered community clusters. So that's a good thing, right? Because now they have that information to be able to make good decisions that might benefit these communities as they start to want to connect in, right? So that was really our goal here. It was really focused on how can these treatment facilities best serve, what's the centralized infrastructure that's going to best serve this potential future vision.
Yeah, I think, like you said at one point, people tend to jump on numbers. And the danger of that is that as a public document, this could be used for people making decisions. And the decision makers should be fully aware of the amount of uncertainty about the numbers. And, if you had ranges, I think that would help.
We'll think about how we can incorporate that thinking. Thank you.
Yeah, and I really encourage people, as Catherine mentioned a couple of times, once you have a chance to look at the full report, more of that detail and areas where there could be kind of caveats added in might be a little bit more clear. And when you do that review, by all means, please flag areas like that.
Yeah.
Kyla, I think you've had a hand up for a while.
Yes, I understand that somebody made a comment that the sewer systems will help property values increase. And the answer is, in the Russian River, that is not likely to happen. And it may not happen in many of the areas that you've flagged. Right now, there is significant changes in values going down, not up. And if you need more information, I'm happy to talk to you about it. But I think that for me, when I look at where we started in this, which was coming up with a wish list and coming down to, well, your wish list is so much money it doesn't work, or it's this way, and oh, by the way, you're on your own to figure it out. That doesn't leave a lot of options for a lot of communities that don't have the amazing capacity that you have. I mean, what you've done is phenomenal, and I think that it is irresponsible to not look at what the real value and costs are going to be. And I would also really like to see some suggestions about where there could be money from other areas, which I understand could be difficult right now. But I'm not sure at this point where most of the communities that you've flagged can go. Sebastopol has great options. Grayton has great options. They're more expensive and people have more money. But I have a lot of concern about where things are moving at this point. So thank you.
I'll just remind folks, sorry to cut the line, Catherine, but in no way is this kind of a funding strategy for the next steps. It's just showing those funding estimates, and I don't know, in my role doing public outreach and engagement, it's better to know, it's better to have a good sense of what a reasonable estimate is and be able to work towards that. So appreciate you putting all those numbers out there. Steve, I'll come back to you in just a moment. I do want to check in with Brenda, Dan, Tina, Todd, some of the folks who haven't had a chance to weigh in quite as much. Any questions for Catherine, since we're getting close to the top of the hour here?
No questions from me, thank you.
Thanks, Tina.
No questions. Yeah, I thought this was pretty well put together, and the logic came down to kind of what I've been thinking for some time. Just without having done any study or having any technical background in it, it just seems like some of it was obvious, but you had to check it out.
Somebody would have asked the question, right?
Yeah.
Others who haven't had a chance to weigh in yet. All right, Steve, take it away.
Just real quickly, at some point in our process, and we've been at this for 7 years, just so you know, there was a presentation to us that there's sort of an optimum size for ongoing support of a sewer district in terms of number of parcels that it serves. And it might be instructive if that is indeed true. And after you get to a certain point, it's too much. And under a certain point, it's not enough to support the ongoing maintenance infrastructure and operational costs of a system. If that's true, that might be helpful to sort of look at these different areas in terms of, do they serve the optimum number of parcels or ESDs, however you choose to look at it, that make for an successful sewered operation. And I just wonder if you ever thought about that, ever heard of it? What makes it?
I haven't heard of an optimal number. I mean, we said you need at least 50 homes to make it worthwhile. But honestly, that was a little bit of a seemed reasonable number. But yeah, that's a good point. I think in terms of recommendations, long term, the priority, but also the larger clusters are going to be the ones that should probably be focused on first.
The number I'm remembering is more like 2,000 or 2,500 units to be feeding into a system to make it make sense.
Well, in that regard, I mean, you go back. I mean, I think we've got 2,000 units total in this entire region. So maybe that plays back to why alternative 1C looks so appealing, because you're hitting that magic number at all going to one facility.
Right. Okay, thank you.
Steve.
And about this, I hope I'm not dominating too much, but
If I can comment on Steve's last comment, I've heard similar dialogue, perhaps dialogue that's come from a former colleague of ours at Sonoma Water. I'm not sure if that's what your source was, Steve, but I have heard that dialogue of, these small systems that we operate are too small to have a stable enough rate base. And if they had more users, or I mean, that was some of the, I think the impetus behind suggesting that regionalization could, add a broader rate base. And I'd heard that similar to what you're suggesting, like we have a plant in Sonoma Valley that's about 3 MGD average dry weather flow that this former colleague felt was more in the range of, and I think it was based upon him looking at some benchmark data. I don't know what his source of benchmark data was on that, but we have had that dialogue that these small systems just need to be a bit larger with a larger rate base to have more stable rates and more affordable rates. So I'm just trying to acknowledge that I have heard dialogue along those lines as well.
yeah, and I saw Anne smiling above as well. I mean, and that just should, if that's good information, it should be included somewhere in this report somewhere. That as you're looking to do things, what makes sense?
Yeah, and I think I will say that the 50 homes, I mean, that's just for the, making it reasonable to build a collection system, right? But all of these alternatives assume you're increasing the number of users that are using the treatment infrastructure, which again was kind of the main focus of the study. And I will note that the cost per user within Forestville, Grayton, and Russian River goes down when the rate base gets expanded under all of these. So that's the incentive for them to move in a direction to bring in unsewered communities, which it has to be a win-win for everybody. But that's, to your point, by adding these unsewered community clusters into these existing treatment plants, that's what makes a more sustainable long-term wastewater operation for the region. I mean,
absolutely.
Yeah. Definitely going out of your own with 1,000 homes at this level is probably not going to pencil out.
Right. We are here at the top. I'm getting a bunch of echo from somebody. There we go. We are here at the top of the hour. I just want to check in with all of our stakeholder committee members and see if there are any closing thoughts. After that, we'll go to Paristu to recap next steps, and then Kent, if you're okay with it, we'll turn to you for closing comments. But any final thoughts by any members of the stakeholder committee?
Are you able to hear this? This is
Sorry, Brenda.
I've been having a hard time, so can't.
Understood. I'm sorry, Brenda. I'll follow up with you following the meeting, and any comments you have, I'll get if staff is comfortable with it, I'll get inserted into the meeting record as well. Sorry about the technical issues there, though. All right. Final thoughts from any other stakeholder committee members? Okay. Let me go to Paristu then to recap our next steps.
Okay, thanks everyone for staying and listening to this long presentation, although we covered a lot of information here. And hopefully we will have the draft report to the North Coast Regional Water Quality Control Board and you at the same time by end of November. And again, we'll have about a month for a stakeholder committee to review the report and then have the comments and feedbacks back to us by January 2nd of 2026. Then we'll review those internally and we will have another meeting in the week of January 12th or probably on that date to discuss and review the comments together, like one of these sessions. And then we'll gather all the comments and make sure that we'll address those in the revised draft that we'll send to the North Coast Regional Water Quality Control Board in early February. The reason that we need to submit the draft to the North Coast at the end of November is because of the requirement in the enhanced compliance action. So we wanted to make sure that we will address all the comments that you have. So we reached out to the Regional Water Quality Control Board and asked them that if we can have an extended time for this revised draft, and they approved it. So now that we have a little more time, we can have the all the comments from the stakeholder committee incorporated in that revised draft report to the board in February. Thank you.
Stu, so stay tuned. We'll certainly get invites out for that tentative January 12th meeting to all of you, and be on the lookout for the draft feasibility study for your review. And of course, the review is coming right over the holidays, so as you're digesting all of your wonderful holiday meals, you'll have a little light reading to go over. But really appreciate you taking a look at that as soon as it's out. Let me go to Kent for closing thoughts, and then we'll go ahead and adjourn.
Thanks, Sam. And I don't know about digesting over the holiday. I think more of indigestion when I weighing such things as this. But well, we were correct. There was a lot of information relayed and nearly impossible to take it in. I think this is the second time I've heard some of this information, and it's still overwhelming. So if you're feeling that way, you're in the right company. And there's a lot of hard decisions ahead, a lot of uncertainty that still lies ahead. And clearly we don't have all the answers. It is a high level study, but this is a lot of great information. Catherine, thank you so much. You guys have done tremendous work and really appreciate you laying that out there. I was really interested in perspectives that you laid out in addition to all the costs overall. And I know there's a lot of interest in how are those costs distributed in the future? How does governance happen in the future? There may be more. I'm not saying at the end of this, we have all those answers, but maybe as we move in the technical stage and get into advancement considerations, at least that dialogue can be continued forward and maybe get some further answers. I did find your analysis of what does this look like from Russian River's perspective? What does this look like from Forestville, Grayton? What does this look like from unsewered community members' perspective? Hopefully we'll be able to hear from y'all, maybe in some of your comments, your thoughts on some of those perspectives that were shared as well. So anyway, a lot of great information. Thank you again for hanging in there all this time. And I know these are long meetings. Really appreciate it, and appreciate you going through hundreds of pages of report over the next couple of months. So thank you very much, and hope everyone has a great evening.
Well, thanks so much, Ken. Thank you all.
Thank you, everybody.
Bye-bye.
Thanks, everyone. Have a good night.